Well, hey guys, what's up, game developers? It's Timbot here at Steam Labs, and we've just finished up class. We didn't quite get through the game controller script that we're working on, but we came so close, and it's a really exciting one because this is basically the brains of the whole operation. This is what gets our enemies spawning, and that's pretty exciting. So I thought what I could do is just keep moving along here. I've got a few more minutes of code to do, and I'm going to upload this for you guys so that if you are anxious to get your game up and running, you're going to be able to do so. Now, just a reminder for you, this is a particularly important lesson because this is also showing us how we can integrate new graphics into our game. Now we're going to be using that because we're going to be taking some of the interesting enemies that we create in all of our games and fusing them together into one awesome space shooter game that I'm currently working on actually creating a real arcade cabinet for. And we're going to be showing that off at the Steam Labs Community Night. So you're definitely going to want to pay attention to this lesson. I don't feel bad that I'm making a video for it because you might want to watch it a couple of times. All right. Let's get into it, shall we? Okay, all right, so a quick little reminder here of what we've done so far. We're currently working on this game controller script. Now, to create this, all we did was create an empty game object inside the hierarchy. We renamed it game controller, and then we added a script component. And really that's all this is going to need because this guy is kind of the brains of the operation. He's strictly there to run code. Now just before that, we created a variety of prefabs of hazards here. And we saw how we kind of split things up. Here, let me pull one of these up into the hierarchy just temporarily here so we can sort of remind ourselves of what we did. So we got this pretty sweet looking asteroid here, but it's actually built in two parts. If I expand this hazard right here, we see inside that there's another child in here called the prop asteroid right here. And if we look in the inspector, we can see there's not much to this guy. He's basically just a transform right here and a mesh, right? In other words, he's just graphics. No scripts or anything associated with this guy. Now, if I run this game right now, well, I probably got to finish a little bit of code before I can run this right now. So let me just click on Hazard here, and we can see that, this one's much more interesting because he's got a collider, he's got a rigid body right up in here. He's actually got several scripts associated with them, and each one of these do something slightly different, right? Now, as each of these scripts kick in, as the box collider, gets turned into a trigger and so forth, basically all of the animation and all of the reactions happen at the level of hazard up here. Now, what that means is that if we wish, we can change the graphics that are inside of this. Like we could take this asteroid out, we could drop a different one in, and by doing so, we don't break anything because all of the code related to this is in the parent. Now that's really, really nice. Now keep that in mind as we go looking at the code that we're doing here. So let me jump over to the code for the game controller. I'm just gonna delete this hazard off of here. We'll head back to here. And we can see that right here, we have a nice little drop down that is going to allow us to collect together any of the hazards that we want to use and drag and drop them right up here into the hazards. And what we're after is that our game controller script will use that information to randomly spawn enemies at different speeds and times and essentially create like the waves of our game. So let's head back to the code here, and we'll take a look at the first thing that we did. Right up here, we made a public game object array. Now this is what is allowing us to select multiple hazard prefabs and drop them over into the hazards inside of the IDE here. This accepts a collection that we call an array. Now an array always has a property called length, which is an indication of how many game objects are in the collection, right? So take a look back in the IDE here. You see how right now it says size 0? Well, let me lock off the inspector here. And let me grab one of my prefabs like hazard 1. And I'm going to drop it onto hazards. And you see how that changes and it now says size 1? And then maybe if I grab hazard 2 and I drop it on there as well, right? Now it says, oh, length of 2. And it's saying that because we now have like 2 possible obstacles inside of here, 2 different asteroids. Pretty good, right? Okay, so we're back in the code here. And we can see if we scroll down a little bit, we've got 2 more public variables right now. So what's this first one here? Well, let me put a little note for it. This is basically a little delay that we are doing at the start of the game so that the player has some time to get ready. Hazard count, this is basically how many enemies that we want to spawn in each wave. There we go. And so how do we get this whole thing started up and spawning waves of enemies? Well, right here, we've got our start function. And in class, we talked about what we're doing here with this start coroutine. So basically, start coroutine allows us to run a function in a separate thread. In a nutshell, we talked a little more in depth in class about that. But this is basically like an optimization technique here, because we essentially want to have this just, keep spawning waves of enemies until something happens like you blowing up. So right down here, here's the spawn waves function that we created. And we mentioned that this has a return type on it, whereas most of the functions we've been writing, the return type has been void, which basically says that this function just does its job, but doesn't hand anything back as a result of doing that job. Now, other functions will actually have return types. If you think of a math function, if you make a function that adds 2 plus 2, well, you expect to get a number back, right? You expect to get like an integer or float or something like that back. In the case of spawn waves, what's given back is called an IEnumerator. And essentially, this is kind of a counter for successful operations. And so basically, when we start this coroutine here, we're expecting to get some results back from spawn wave. Now, if we don't get anything back, then essentially we know something bad has happened in that routine. And, we can throw some error messages and we can take some action on it. Now, right here, we are using a little yield to introduce that pause that will happen before our game actually starts spawning enemies. And we're using that start wait variable. Where did we get that from? Well, right up here, it's a public float. So we're going to be able to set that inside of the Unity IDE. So now we get to the point where we were actually spawning our enemies. And so right inside of here, we created essentially a never-ending loop right here. When we say while true, it's a little trick for us saying, run this over and over and over again. Now inside of here, we have a second loop. And what is this for? Well, this is for spawning multiple enemies in a wave. All right, so let's take a look at this loop. Right here we've got a for loop, and a for loop always has 3 parts. The first part is a little counter that we're creating. So we're creating this counter called just simply I, and we're setting its value to 0, right? Now right after that we create the condition. So we're saying run this loop, this whole piece of code here, everything inside of here, run it while I is less than the hazard count. And then the third part of our loop is to increase the counter. And the little plus plus says increase it by 1. See how that works? So we're saying start a counter at 0 and let it run until that counter reaches the hazard count number. Again, where are we getting that hazard count number from? Well, right up here, it's public integer. So inside of the Unity IDE, we're going to be able to specify how many enemies should get spawned in every wave of enemies that happen. So finally, we get down to the point of actually creating our enemy that we want to spawn. So right here, we are looking into that hazards collection, and we're using a little math trick called the random range. So random range is best explained by that old game you play where you tell your friend to pick a number between 1 and 10. We're doing the same thing here. We're saying pick a number between 0 and the hazard's length, or in other words, the total number of enemies that we have submitted through the Unity IDE here. So if we were to just jump quickly back to Unity IDE, that's where that size comes in, right? So it knows we've got 2 asteroids in here right now. So what we've essentially done is said, pick an asteroid from this list. Pick a random asteroid from this list here. Back to the code. Now that we have a random asteroid, well, we have to give it a position, and we probably want to randomize that as well. So this is the point that we were basically running out of time in class. So I'm going to pick it up from here. So I'm going to say, let's create a random position here. And we need to do it with a vector 3. Because in a 3D game, there are always 3 parts to a position, aren't there? So I'm going to, again, go to random range. And we're going to plug in a couple of values here that depend on some variables. But then we're going to go back and we'll create those variables, all right? So I'm going to say random range. And it's expecting a few properties. So I'm going to refer to a spawn values .x and a positive spawn values .x, right? I'm going to talk about this. So, but basically, this first random range is going to pick a number between, it's going to pick a number that will set the x position of this new hazard that we've created here. So what do I mean by that? Well, if we look back in the Unity IDE, we essentially want our enemies appearing up here over the top of the screen. So then they will, come down the screen towards our ship here. That's our game mechanic. So if we're picking a random range for x, that is basically going to be the horizontal positioning of this enemy that we've just spawned, all right? We want to randomize it. It'll make for a much more interesting gameplay than if it's a really recognizable pattern. So that's going to give us our first value here. Now we also need to give it a y and a z value. Now this is a little bit simpler. We can simply say spawn values dot y and spawn values dot z. Now you'll notice we're not using a random range for the y and the z. And the reason why, if we go back to Unity, is because we really only care about the randomness horizontally, right? We're going to spawn these off screen outside of the player's view here. So the player isn't really even going to know, if we've randomized it vertically or not. And in the Z depth, well, we don't want to change that at all. Because if we go back to our scene here, and we start spinning around here, we can see that basically our background is flat. So we want to spawn all of our enemies at the same Z depth as the player, so that as they come flying down the screen here, they can actually have a chance of making contact with the player and exploding them, all right? So let's head back to the game view here, and we'll head back into the code. And I think we're pretty good. Now you can see it's highlighting in red spawn values. because we haven't actually created that variable yet. So let's do that first, just so we don't forget it. So we're going to go right up to the top here. And same place where we've got our other variables, let's make a public vector3 spawn values. So because this is public, we will once again be setting this through the Unity visual interface, the IDE. Right, now that should get rid of our red underlines if we don't have any typos, and it looks like it has. So that's looking pretty good, all right? So let's put a little note for ourselves so we can just keep in mind what we're doing here. Pick a random position off screen for the new hazard. All right, let's see. Is there anything else we want to do here? We probably want to set the rotation value for this thing as well. So let's stick in a quaternion. All right, quaternions are always involved when it comes to rotational values here. So we're going to say quaternion right there, spawn rotation equals quaternion dot identity. So here we are basically saying, like, you know, set the rotation to essentially the same rotation as the quaternion on this game object that we're creating here. So the reason we're doing that is because we are basically handling random rotation in a separate script that we attached directly to the asteroid. If you remember, basically we made a small little component that sets a random speed of rotation and a random direction of rotation so that these asteroids kind of spin through space as they're falling here. So we don't have to do too much here. Let's see here. Now the only other thing we really need inside of here is a little delay between spawning these. Because if we don't put in any kind of delay, essentially, if we've asked for like 5 to be spawned, they're going to appear all at one time. And so essentially they're going to appear in a straight line horizontally, and they'll all fall in like one big mass. What we want to do, if we look back in the game here, is we want to have them sort of appear like boom, 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 boom. Now as soon as they appear, they're going to start falling, right? So if we put in a little time delay between spawning the individual asteroids, then the effect will be that they'll have a nice random pattern as they fall down the screen here. So let's do that. And we can do it simply by saying yield return new, and we have a function specifically for this called wait for seconds, and we'll use spawn wait. There we go. And as you may guess, this is turning red because we don't yet have that variable. So we're going to need to go up and make a public float for spawn wait. So let's head back up to our variable declaration. Maybe we'll put it right near the start wait because it's kind of related. We'll say public float, and what do we call it? Spawn wait. Delay between spawned enemies. There we go. And if we go back down, yay, red underline is gone, and that is good to go. Yeah, this is so close to being finished here. The other thing that we need is a little delay in between waves. So you see how this works? We start off with a little delay before the game starts. Then we have a little delay in between each enemy that is spawned, and we do that in waves, and we have a little delay in between each wave. So let's throw in one more, yield, return, new, wait 4 seconds, just like that. And we'll pump in wave wait will be the variable name we want to use. And by now, you're probably recognizing when we see that little red underline, well, that's a hint for us that we haven't created that variable. So let's put that right up here with the other weights. We'll say public float wave wait. And I'll leave a little note for myself, delay between waves. There we go, and hopefully that makes sense. Now, why are we doing all this customization here? Well, it's basically about tweaking gameplay. You know, usually when you start making a game, you have some ideas about how it should work, but when you get into testing and you get feedback and you look at how people play the game, you realize, oh man, you know, that this part should have been a little faster. This part could be a little slower. It's too frustrating for people. So we're building in for ourselves a large degree of customization. We can essentially control everything about the speed of this enemy generation here. Now this is why we have a game controller, because the game controller becomes kind of the central control for the whole game. Inside of here, we find the main game loop, which in this case is spawning wave after wave of enemies. So taking a look in it, I feel pretty happy with the code that we've got here. So I'm going to save this. We're going to head back to the Unity IDE, and we'll see if all these public properties we've created start showing up. We'll see if we can fill those in and actually give this game a try. So back in Unity, what do we see here? We've got a start weight, a spawn weight, a wave weight, a hazard count, and then we've got right here spawn values. We'll see how we can fill that in, because this requires 3 properties inside of here. Okay guys, we're back in the Unity IDE now. We've written the code for our game controller, and now we need to fill out these properties here. So let's start with some of the easier ones that we've got. How many seconds do we want to wait before we start the fast and furious action on these players here? Let's give them, I don't know, let's give them 2 seconds. You can mess with this as you wish. All right, and now we've got our, so that's our, it's the start wait that I want to begin with here. So I'm going to start with a 2-second delay. There we go. Now the spawn rate, that wait that I was just filling out there, this is basically the time that happens in between spawning enemies, you know? So how frequently do we want to spawn these enemies? Why don't we say like maybe, I don't know, 1.2 seconds in between enemies? And then how long do we want to wait in between waves of enemies here? Let's say somewhere around 2 seconds. Let's say that it takes about 2 seconds for these guys to clear the board in between waves. And then finally, probably the most important one here is like, how many enemies do we want to spawn per wave? So why don't we say something like, that's a tough one. I'm going to say 5, right? Now, if I grab one of my hazards here and I pull it up into the hierarchy here, you can see roughly the physical size of this. It's a little bit larger than the player ship here. So if 5 of them are spawning, you're probably going to have the screen, you know, fill up pretty well, but have enough gaps in between them that a skillful player could sort of maneuver in between them and blow them up quick enough. Now, as I say, we can tweak these values as much as we want, because we've basically got all of these properties that we can mess with. Now, the one that we haven't filled out yet is the spawn values here. Okay, now we've got this values filled down here. The last one that we have to set is this spawn values here. Now we could do a bunch of calculations about the screen size to figure out the range that we want to set these to. But to me, the easiest way is just to do it visually. So if I grab this little hazard that I've pulled up on here, and I click on it, we can see that right over here, we've got some X, Y, and Z values for the position right here. Now, if I start to pull this over to the left, we can see that this is probably about as far as we want to go horizontally. And what is our X position right now? It's like 3.27, right? So if we go back to our game controller, and we set 3.27 in the X value here, what we are essentially doing is saying that the X value can be anything between 3.27 positive, in other words, over to the right. So if we want to kind of simulate that, if we move this guy over right here, and we even we could set it right here, 3.27, he's going to be allowed to go over that far. If we make that a minus 3.27, he's going to be on the other side here. Now, this might make the code we've written make a little more sense here. Because if we were to go back to that, and we look at that spawn position we're doing here, we used a random range, and we said, do a negative of the X value, and do a positive of the X value. And this is us saying, pick between the minus version of the X value and the plus version of the X value. Now, if we go back to the Unity IDE, well, what have we set on game controller? 3.27. So it's going to pick a position in the X value anywhere between minus 3.27 and plus 3.27. Which, as we've illustrated, is pretty much what we need. Minus 3.27 plus 3.27, right? So anywhere in this range is where our enemy is going to appear. Now, what about the Z value and what about the Y value? Well, in this top-down view, the Y value is this property right here. So if we want to be really sure that this is off screen, we can move this up, maybe right up around here. We know that the background is framed pretty nicely. So if it's above the background, then it should be off screen when we spawn this thing. So what is our Y value right now on this? It looks like it is 0.67. Now, but look at this, guys. My bad. Right? It's actually the Z value that we need to be concerned about. So by grabbing the handle and actually visually moving it here, I remind myself that in this top-down view, the Z value is actually the vertical here. Now, I probably could have got that also by looking up the widget here, but it's been a long day and I've been writing a lot of code. So we're going to set the Z value of the game controllers to about 7.6. So let's go back to that game controller. And on the Z, we're going to say 7.6. There we go. And now we get to that Y value, which is probably easier to see if we spin around our game view a little bit here. So let's go a little bit more perspective-wise. And if we go right to the side here, well, we can see that our rock is actually pretty far above our ship, right? We should probably bring that down a little bit to bring it a little more in line. We might have to mess with this arrangement a little bit, but right now it looks like 0.25 is going to be roughly what we want. So let's go back to our game controller. And let's throw that 0.25 in as a Y value. There we go. And just like that, guys, we're pretty much ready to go here. So let's get rid of our little test rock here, hazard 1. Let's bring back our game controller. Right now we've got hazard 1, we've got hazard 2 in there. What else have we got? That looks pretty solid. This looks pretty solid. Let's get this one in here as well. So first of all, one thing I'm going to do so that I don't accidentally mess up my inspector here, I'm going to click on the game controller right here, and I want to keep this game controller in the inspector. Now that's going to go away as soon as I start clicking down here in my project assets, but I can stop that from happening by locking it. It's hard to see, but there's a little lock right up here on the top right of the inspector. So let me lock that off, and then I'll be able to grab my little hazard 1 that I want to use here. These could probably be named a little better. Drag it on the hazards, and see, he doesn't replace the others that are in there. He actually joins them, and we can tell because it's now got a size of 3. So I think we're in a pretty good place to actually give this a test run here. Let's see what we got. Wow, guys, I am getting a little bit tired. We missed the most important line of code inside of our script here. I have definitely figured out what's going on here. Let's go back to the script for our game controller here. And we did everything right in here. There's no errors, there's nothing getting thrown here. But the most important thing we need to do is actually put that hazard on the screen. And to do that, we need to do an instantiate call. Looks like this. Instantiate. We made all the information we needed for this, but we didn't actually put it on the screen. So we're going to say instantiate that hazard that we've asked for. Put it in the spawn position we created, and give it the spawn rotation we created. There we go. So we had this whole routine running, and it was creating all the information, but then visually it wasn't actually putting our hazard on the screen. So let's give that a save. We'll head back. Man, there's always debugging to do, eh? So let's go back to our game view, and let's try it one more time. Okay, so we got something here, right? We definitely do have hazard spawning here, and they're appearing in waves with delays in between each one. It's pretty good. Let's see what happens if we contact one. Boom. So we see how they both disappeared. Now you probably notice it's pretty obvious at the beginning there that our background disappeared. So what's up with that? Well, my guess is that our asteroids are probably making contact with that background plane. If we go to our scene view and we rotate this around a little bit here, right? And we grab one of our hazards and bring it out just so we can, well, maybe not that one. Cube's not so helpful. Let's grab one of the asteroids here. And if we kind of zoom in a little bit, you know, I'm guessing that what's happening is that as this thing's tumbling and its rotation is changing, that it's actually striking against the background plane that we've got here, and basically destroying it, because as you can see, it's got this destroy by contact script that essentially obliterates things it runs into. So if we want to test this theory, what we probably need to do is grab the background, pull it down a little bit, and then let's give it another run and see what happens. Let's get rid of this little one we've got here. We'll give it another run. It's going to take us back to the game view, and there you go. Right? So I mean, obviously we've got gameplay tweaks to do here. We're probably boom. We're probably going to adjust the speed of everything. Maybe I'll just run it one more time just to make sure that we've still got the fire rate working here. Yep. I mean, they're slow, super slow, but I can probably blow up rocks, you know? I don't know. It's an interesting game mechanic. Might be something to this. Maybe you've got like a super slow shot or something. Yeah, but you know, all this is tweakable. We can go in and we can play with these numbers, and you know, that's a fun part. Like that's our game design. If you remember in the very first class, we talked about the different career paths between game art and game design and game programming. We're getting to try all of them, you know. You tweaking the UI, that's definitely falling inside of game design, so that's going to be a lot of fun. So I think we're pretty good on that. And that's going to wind up this script. A couple of misadventures along the way, but I think that's pretty typical. I think we did not too bad here. As a reminder to you guys, I'm going to be looking to you to come up with your own enemy designs that we can bring together inside of one game here. So you're going to need to think about the meshes that you want to use. You might want to take a look on the Unity store to see if there's any assets that appeal to you on there. You're also going to want to think about movement. We can create custom movement scripts that we can drop on your particular enemy, and then we'll add it into the random spawner and let's see what it does. Think about how it's going to attack. Think about how it might explode. Lots of cool stuff that we can do. All right, I'm going to wind it up there. I hope this has been helpful for you guys. Not a super long script when you get right down to it, but probably the most complex one we've done up to now. We've got like a loop inside of a loop. We've got, you know, vector threes and quaternions going on inside of here. If you don't fully, you know, if you're not fully comfortable with the math of that stuff, well, vector 3 is your position stuff and quaternions your rotation stuff. And each one of these has 3 parts to it, which are the X, the Y, and the Z values, because it's a 3D game that we're working inside here. If anybody wants to discuss that stuff a little bit more, then definitely let me know. But for now, I'm pretty happy with how this thing is running, and I'm going to wind it up there. I'll look forward to seeing you guys in the next one.